Hi. So in our sessions, we have already studied a lot of pump selection. For example, in plumbing, water supply, we have studied transfer pump selection, booster pump selection, hot water recirculation pump selection. Drainage, we are having sump pump selection, sewage lifting pump selection. And HVAC, we will be having for chiller side primary pump selection, secondary pump selection, tertiary pump selection. Then cooling tower, no, condenser water pump selection. So those things are in few sessions are in plumbing sessions, few sessions are in HVAC sessions, and in few sessions are in firefighting, so diesel pump, electrical pump, jockey pump selections and all. See, so in this video, I'll be explaining what all things has to be considered when you are selecting a pump, not only a single pump, all the pumps that we are using in the MEP. Because I'll be explaining what is negative suction, what is positive suction, when the priming has to be considered, and what is open loop system and what is closed loop system. So all those things I will be explaining in between, and the things that you need to consider at the time when we are doing the hydraulic calculation or the pump head calculation, I will explain. See, first I will be explaining what is negative suction. People might be already aware about it, but let me explain. And what is the difference between negative suction and positive suction? Okay, negative and positive suction. Negative suction and positive suction. For example, if you are having a reservoir, okay, and this is a water level, and this is your pump. Let's say it's a centrifugal pump, and this is a pump suction pipe, and this is a delivery pipe, let's say. Okay, up to here. So if the pump has located above the water level, this is called negative suction, and you're having another reservoir, and this is a water level, and the pump has located on the bottom, and this is a suction pipe. So the water level has located above the pump suction side. This is called positive suction. In negative suction, positive suction will be always safe. So whenever it is possible, most of the firefighting systems and all, we will be trying to arrange a positive suction only. And in water supply, the pump that we are dipping inside, no, like a submersible pump that we are dipping inside the water, that is like a positive suction only. But in every time, sometimes no positive suction might not be possible. Negative suction we might be using, right? So the problem of negative suction, you have to do priming. Means here we will be proposing a footwall. So the footwall will be holding the water inside always. It will always allow the water to flow one side when the pump is taking the suction. And the priming is the process in which we will be filling the water until the impeller point to the pump suction point. So from this point to the impeller midpoint, we will be filling the water. Otherwise, what will happen? For example, instead of water, if you are having air inside the suction pipe, when the impeller is rotating, air only will rotate. The density of air is just 1.2 kilogram per meter cube, and density of water is nearly 1000 kilogram per meter cube. Correct. So it is not practically possible to lift the water by the help of air, because air is much lighter than water. So that's why, since we are filling the water in the suction pipe until the impeller, when the impeller is rotating, water only will rotate. So the water, when it is rotating, it can create the suctional forces, right? So that's why the priming we have to do in negative suction. And in negative suction means when we are selecting the pump, for example, we will be having open loop pump, closed loop pump. We can discuss that. And the major losses that we need to consider at the time when we are selecting a pump is, the first one is material loss. That is due to the pipe only. Due to the surface roughness of pipe material, the material loss will come. That we have to consider. I will explain that. The next one, fittings losses, minor losses, fittings losses has to be considered. Within the loop, we will be having elbow, T-joint, valves and all those things we have to consider. Then we have to consider static head. Static head for open loop pump, that is mandatory. I will explain what is open loop. So if you are having a pump, and if the water level is there, this is your suction head, and the pump will be delivering the water upside. This is your delivery head. So this is your static head. Static means this much gravity the pump has to overcome, then only the water will be reaching there. No, so that's why in negative suction pump, the suction head has to be considered. So suction head plus delivery head, you will be getting the static head. But in positive suction, you can imagine this is your suction pipe and this is your delivery pipe. Let the suction head there is no height difference. Suction is 0 only. Delivery head. So your static head is equal to your delivery head. Most of the cases, the positive suction case, the suction head you need to consider 0 in positive, but in negative suction case, you have to consider the suction height as well. When we are calculating the gravity head, means static head. Okay, that's the difference between negative suction and positive suction. Negative suction, we have to do priming. Positive suction, always the water is there in the inlet side of water pump. We don't want to consider the priming. And also in negative suction, you need to consider the suction head, and in positive suction, it is not mandatory. Okay, the next one, what is closed loop and open loop pumping? For example, if you are having a pump, at any point in the pumping circuit, for example, this is the suction and this is a delivery. At any point within the pumping circuit, if the pipe is or the pumping is exposing to the atmosphere, or the pipe is opening to the atmosphere, that is called open loop pump. In open loop pump, always we need to consider the static head. Correct, because the pump has to lift the water, it has to suck the water until here, and after that it has to lift the water to through the delivery. Means it has to overcome the gravity, then only it can deliver the water up to the required point. Okay, so open loop pump, the pipe suction, or means at any point in the pumping circuit, if the pipe is exposing to the atmosphere, that is called open loop pump. Static head is mandatory when we are calculating the open loop. But in closed loop pump, for example, if you are having a closed tank, okay, in which a pump is, you're having a closed tank, let's say. A pump is taking a suction from this point. Let's say this is a pump. Okay. And after that, the pump will be delivering the water. So it will be reaching here. And this is your tank. So this is our tank. So everywhere we are having water. Means within the tank, within the suction pipe, within the delivery pipe, always we will be filling water inside once the system has erected, it has constructed. So the role of the pump is to circulate the water through the loop only. Means no need to lift the water, right? Because already the water is there, no need to overcome the gravity. The role of the pump is to simply circulate the water through this loop. That is called the closed loop. So when you are doing the closed loop system, static head is not mandatory, because no need to overcome the static head, because already we are having water everywhere. Okay, so what are closed loop pump, what are open loop pump we are having in this MEP cycle? For example, in water supply we are using a transfer pump. The function of the transfer pump, for example, if you are having an underground tank and you are having an overhead tank, so the transfer pump will be taking the water from the underground tank, and after that it will be lifting to the overhead tank. That's the role of transfer pump. So transfer pump is an open loop pump only. When we are doing the pump head calculation, you need to consider static head. And next you will be having booster pump. Correct. As per international plumbing code, most of the water closet and all, for the proper operation, at least 20 psi means 1.4 to 1 by 1.5 bar of pressure be required. Residual pressure means after overcoming all the pressure losses, the pressure that is available at the tip of a pipe is called residual pressure. So minimum 20 psi of residual pressure be required for the proper operation of water closets and all. For example, if you are having an overhead tank, from the overhead tank, if you are taking water downwards, by gravity, sometimes we will not be getting it. In the water supply system, we have discussed that in very detailed manner, or that transfer pump calculation video I have uploaded in our YouTube channel as well. You can watch that. Correct. So only by gravity, sometimes we will not be receiving that pressure. Then we have to go for booster system. Correct. If by gravity, if we are not getting, then we will be going for the booster system. Booster system, we will be having direct system and indirect system. Direct system means, for example, indirect system I will explain first. For example, this is your building and this is your underground tank and this is your overhead tank. From the underground tank, transfer pump will be lifting the water and it will be delivering to the overhead tank. From the overhead tank, we will be having gravity line and we will be having boosted line as well. A booster pump will be there. Means we will be transferring the water from one tank to the another tank. From that overhead tank, the booster pump will be taking the water, then it will be delivering downwards to get the sufficient residual pressure. No? This is called indirect system. Indirect system. In indirect system, static head is negative only. Means you can imagine when the water is flowing downwards, no, and the gravity is an advantage there. So when we are calculating the indirect system for booster pump, no, so topmost floor only we will be considering, there only we will be getting very minimum gravity pressure. But if the height is increasing, gravity pressure is increasing, the booster load will decrease there when the elevation is increasing. So where we are getting the minimum gravity pressure, in that we will be considering as a critical path. Accordingly, we will be selecting the booster pump. So that's why when we are doing the indirect system of booster pump, we have to calculate the material losses, we have to calculate the fittings losses, we have to calculate the residual losses, we have to add together. In that value, we have to deduct the static head. Static pressure is negative in indirect system of booster pump. Then we will be having direct system as well. Okay, direct system means, for example, this is your building. The entire building will, for example, you are having your underground tank. The pump will be taking the water from the underground tank, and after that, throughout the building, the pump will be delivering, means the water supply through the pump only we will be delivering. So if there is no electricity, you will not be getting water everywhere. No? So that's why we should have a perfect diesel generator system everywhere. This is called direct system. Means we will not be transferring the water from like underground tank to overhead tank. Rather, from the underground tank or any other tank itself, the pump will be taking the water throughout the building. All the fixtures will be supported with the booster pump. Booster pump will be having a duty standby arrangement. Sometimes 2 duty, 1 standby. That is with respect to the load, we have to divide it. An expansion vessel will also come there to adjust the on-off cycle of the booster pump. Correct. So when we are calculating the indirect system, static head is negative. But when we are calculating the direct system, from the suction side to the delivery, this is open loop only. Open loop only. Static has to be considered. Means it should be a positive value. Along with the material loss, fittings loss, then residual pressure, static head instead of negative, we have to add it. That's the difference of booster pump, direct system and indirect system. Any other open loop pump we will be having? Yes. And the next one, in drainage, we will be having sump pump. Sump pump. Then we will be having a sewage lifting pump. Sewage lifting pump. Then in HVAC cooling tower, condenser water pump. No, condenser water pump means like a cooling tower water pump. All these pumps are open loop pump only. So when we are calculating open loop pump, what all losses we need to consider? What all losses, what all things has to be considered when we are selecting the open loop pump? For example, transfer pump. When you are calculating the transfer pump, let's say transfer pump, the first loss that you need to consider is material loss only. Means from the pump suction side to the delivery side, you have to calculate the total length of pipe into head loss used for design. Material loss is length of pipe in critical path. Length of pipe in critical path multiplied by head loss used for design. Head loss sometimes you might be doing in Pascal per meter, then the length of pipe should be in meter, or sometimes you might be doing in feet per 100 feet, then the length of pipe should be in 100 feet. Okay, and length of pipe should be in feet up there. That is material loss. And I'm not doing any calculation here because I'm just giving you a concept, because a lot of students were asking this doubt. That's why. The first one is material loss. That is due to the surface roughness of pipe material. Not pipe is 100% smooth. Due to the surface roughness, frictional forces will be generated. That's why pressure losses will come. So material losses is length of pipe into head loss used for design. At the time when we are doing the design, pipe sizing, we will be having a head loss value. That head loss value you have to multiply with the length of pipe. You can calculate it. The second one, you need to consider the fittings loss. Fittings loss value by the help of equivalent length concept. That it means each and every fittings we will be converting into the equivalent length. That data is available in every standard. Even IPCT is available, UPCT is available, NPCT is available. Every standard they have given, even British standard also they haven't given the fittings losses. For example, one elbow is equal to, for example, 50 mm elbow is equal to how much meter of straight pipe. Like that, each and every fittings losses we will be converting into equivalent length of straight pipe, and after that, that length of equivalent length of pipe multiplied by head loss used for design, we can convert that into the fittings loss. Okay. The third one, we need to consider the static head. Means from the suction to the delivery, how much vertical height it has to overcome. So that height into rho into G. Rho is density of water 1000 kilogram per meter cube in SI metric. G is acceleration due to gravity 9.81 meter per second square. H suction plus delivery, how much static height you are having, that vertical height, that you will be getting the static head. And the fourth one is residual pressure. After overcoming, for example, if the transfer pump will be delivering the water from suction to the delivery, if you're overcoming, considering material losses, fittings losses and static head, water will be reaching there, but you need an extra push. After overcoming all the pressure losses, the pressure is available at the tip of pipe is called dynamic pressure or residual pressure. Transfer pump and all residual pressure is not mandatory, but even though like 1.8 meter per second velocity we require dynamic, that is equal to somewhat like 1600 Pascal, somewhat like less than 5000 Pascal only anyhow we have to consider for transfer pump. That is your residual. But when we are calculating the fire pump and all, we need like a 6.9 bar of residual pressure for like landing valves and all. That is different. So these are the things that you need to consider for open loop pump, transfer pump. Booster pump, the same. You have to consider the material loss. You have to consider the fittings loss in the critical path. Transfer pump, we are having one loop from the suction to the delivery. This is a loop. That loop we'll be considering as the critical path. What is critical path? The path in which the maximum pressure losses can come, that is called a critical path. If the pump is able to overcome all the losses that is going to happen within the critical path, then all the other branches is within the critical path only, so water will be reaching there. That's a concept. That's why when we are selecting a pump, you don't want to consider all the loop that we are having within the circuit. Only the longest branch in which maximum pressure losses can come, that path only you have to consider. Sometimes the critical path might be the longest branch or the branch with the maximum number of fittings. Okay. Suppose two branches we might be having. Both the branches, if you are having doubt, both the branches you have to do the head calculation. Both the branches where you are getting the maximum value, that branch you have to consider as the critical path. That loss you have to consider as the pump loss. Pump head calculation, you can consider that branch. Okay. So even booster pump also, material losses you have to consider, fittings losses you have to consider, static head you have to consider. See, booster pump for direct system, when you are calculating the static head or when you are calculating the losses for direct system means from the suction to the delivery, this might be the critical path, the longest branch in which there only the pump has to overcome the maximum gravity. This we need to consider as the critical path. But in indirect system means the pump has located in the top side, and after that if the pump is delivering downwards, that is called indirect system. In indirect system, for example, if it is a multi-story building and this is the topmost floor, there only, and you are having an overhead tank, due to the tank height and the pump location, here only we will be getting the very minimum gravity pressure. So the topmost floor the pump is delivering, booster pump is delivering, that floor you need to consider as the critical path, because there only we will be getting very minimum pressure. So indirect system where the pump is able to deliver the lowest pressure, that you need, or where the pump, where by gravity, where we are getting the very minimum pressure, that branch we need to consider as the critical path. Based on that branch, you have to do the hydraulic head calculation. So when you are calculating the sump pump for indirect system, static head should be the negative value, means you have to deduct it, and for direct system, static head should be the positive value, you have to add it. Residual pressure for booster pump and all, that is totally varying with respect to the sanitary fixtures. For example, some manufacturer will be saying for a shower set we need 45 psi of proper operation pressure for a proper operation. So any manufacturer recommended value is there, then residual pressure you can consider accordingly. But as per international plumbing code, most of not the pressure assisted, normal a flush tank water closet, for the proper operation we need 20 psi of residual pressure, means 1.4 to 1.5 bar of residual pressure we required, nearly 1,40,000 Pascal of pressure we required there. So that 20 psi or that equivalent value you can consider as the residual pressure. You can add together, accordingly you can calculate it. Sump pump also, sump pump means like you will be having a small sump in the basement for drainage and all the drainage water that is accumulated in the basement will be coming and accumulating in the sump. From the sump, the pump will be lifting the water to the ground or to the public municipality line, whatever it may. There also you have to consider like material losses, fittings losses, static head, residual pressure, like 5,000 Pascal is more than sufficient for sump pump. Sewage lifting pump, same calculation. like material losses, fittings losses, static head, residual pressure, like a 5000 psi is more than sufficient there. But in only difference when you are doing the sewage lifting pump, the density of water will come nearly 1000 kilogram per meter cube. Density will come 1000, but density of sewage will come slightly more, 1020 kilogram per meter cube. 1020 to 1050 kilogram per meter cube can come for the domestic waste and all. So in calculation, density difference will come, that you have to consider. Cooling tower water pump is an open loop pump only. When you are calculating, you have to calculate the material losses, you have to calculate the fittings losses, you have to calculate the static head, and just 10 psi of residual pressure we have to consider. But instead of that, in cooling tower, we will be having a spray nozzle. As you know, after removing the condenser heat, and when we are calculating the cooling tower, definitely you have to consider what? Okay, let me clear it. So cooling tower, the function of the cooling tower to extract the condenser heat of water cooled chiller, right? So cooling tower, first you have to calculate the critical path you have to find, then you have to calculate the material loss of that. And after that, you have to calculate the fittings loss of that circuit. The third one, you have to calculate the condenser coil drop within the shell and the tube condenser heat exchanger. No, condenser coil drop you have to consider. Shell and heat exchanger coil drop you have to consider. The fourth one, definitely static head you have to consider. Means sometimes the cooling tower might be located in the roof side, and chiller might be located on the basement to avoid vibrations and all, in water cooled chiller. So static head also you have to consider there, how much gravity it has to overcome. The next fifth one, residual pressure you have to consider. Residual pressure of the spray nozzle you have to consider. For example, from the we will be having spray nozzle. So in the critical path, last one or two nozzles, to overcome the pressure drop through the nozzle, we will be getting from the manufacturer. That will be equivalent to nearly 10 psi and all, approximately near to 0.7, 0.8 bar. That you have to consider the residual pressure. By adding everything together, you can calculate the cooling tower. So all these pumps, transfer pump, booster pump, sump pump, sewage lifting pump, cooling tower pump, all these are open loop pump only. Gravity, static head you have to consider for all these pumps. But in booster pump, sometimes for indirect system, the static head will be negative. Direct system, it might be positive. That's the difference. And closed loop pump. Closed loop, we are having 3 pumps within the, most of the cases, like we will be using 3 pumps. The first one, chilled water primary pump. Then chilled water secondary pump. Then chilled water tertiary pump also can come. And that is in HVAC. In water supply, we will be having hot water recirculation pump will also come. Hot water recirculation pump can also come. These are closed loop only. So when you are doing the closed loop systems, you don't want to consider what this one, static head. So when you are calculating the primary pump, the role of the primary pump is to circulate the water through the chiller only. Correct. See, we will be having variable primary system. Chilled water circuit, we are having primary only system, primary secondary system, primary secondary tertiary system. Correct. Then variable primary system. If it is a primary secondary system, the role of the primary pump is to circulate the water through the chiller side, evaporator. The role of the secondary pump is to circulate the water through the building until the primary pump suction. In that scenario, when you are selecting the primary pump, you have to consider the primary pump critical path loop material losses. You should consider the fittings losses. Sorry, you should consider the fittings loss. Then you should consider the chiller evaporator coil drop. Okay, material loss is same, length of pipe into head loss used for design. Fittings loss by equivalent length concept, or as per ASHRAE K factor, K into velocity square by 2. Using K factor also we can calculate as per ASHRAE. Evaporator coil drop we will be getting from the manufacturer. Okay, this is primary secondary system. But in variable primary system, we will not be having secondary pump there. Then you have to calculate the material loss, you have to calculate the fittings loss, you have to calculate the evaporator coil drop, plus chilled water supply pipe, chilled water return pipe, the entire loop critical path you have to consider. The biggest in the hydraulically remotest, the longest branch in the last, you will be having a cooling coil, an HU coil or fan coil unit coil. That cooling coil drop also you should be taken into consideration. That is for variable primary system. Normally primary, secondary loop, primary system, only these three things you have to consider. Variable primary system, the primary pump only will be circulating the water through the chiller. Then it will be the same pump system only will be circulating the water through the building itself. Then in that scenario, along with the chiller evaporator coil drop, hydraulically remotest critical path, in the last branch, the cooling coil pressure drop also has to be considered. Okay. So the entire loop, chilled water loop, has to be critical loop you have to consider for a variable primary system. So when you are calculating the secondary pump, in primary secondary system, secondary pump only we will be connecting the VFD. Anyhow, those things are very lengthy topic. So in the chilled water side, we have already studied it. It will come nearly 15-20 hours, right? Okay. Secondary pump, when we are selecting, the same way. In the critical path, from secondary pump will be taking the water from the primary pump delivery side, or in the chiller delivery side, it will be header, it will be taking the suction, and after that it will be delivering through the building through the chilled water supply side, then it will be serving through all the coil, then it will be coming through the chilled water return until the primary pump suction. So in that critical path, in the longest branch, you have to consider for hydraulic calculation, the material losses you should consider. Then you have to consider the fittings losses. Then you should consider the coil drop. Coil drop of the last biggest machine, means if you are having a fan coil unit, and if you are having an air handling unit, or if you are having a fresh air handling unit in the last critical path, that coil, which is the biggest coil, in which coil we are getting the maximum pressure drop, that pressure drop you have to consider for secondary pump calculation, and you have to add together, accordingly we can calculate. Tertiary pump, when the secondary pump is not able to deliver, the secondary pump is not having the sufficient head to deliver for the largest building or the longest building it has located far away. In that scenario, tertiary pump will be using as a booster support. Means tertiary pump will be taking the suction from the secondary pump delivery side. From there, the tertiary pump will be delivering through the building that is located far away. Then it will be giving the return, and the return will be connecting to the return side of the secondary side. Primary pump. Okay. That's why in that scenario, tertiary pump, when you are selecting, the same way only secondary pump, from the suction to the delivery, means from chilled water supply side to the return side, material losses, fittings losses, coil drop you have to consider. Because since it is a closed loop, static head is 0 for all these pump. Hot water recirculation pump, for example, if you are having a building, top side we will be having a centralized water heater. So the centralized water heater will be having hot water line that is delivering downwards and or upwards, whatever it may. Then it will be, if it is indirect system, a direct system can also come. It's an indirect system. That's why if we are the water, let's say like 60 degrees Celsius of water we will be keeping inside the system. But night time people might not be using the hot water. So when daytime, so early morning 5 a.m. they will come and they will use. So and let's say like a night at 12 p.m. to morning 5, people might not be using the hot water now. So what will happen? The water will be staying within the pipe, and let's say the water temperature might be 60 degrees Celsius inside. And even though it is perfectly thermally insulated, what will happen? No, in the night time the heat rejection will happen there. So in the morning, early morning, when the people are using the water, up to this point, no, the pipe will be carrying a volume of water. All those volume of water has to flow away. Then only people will start getting the hot water. This scenario has to be avoided. Otherwise, means we have to make sure that always within the building we will be getting continuous hot water supply. So that's why we will be proposing a pump there. Okay, what this pump will do? The pump means hot water recirculation pump. Okay, if this is your centralized water heater, and this is your hot water recirculation pump, and this is your hot water supply line. Okay. So the hot water recirculation pump, from the hydraulically remotest branch, it will be taking the suction. It will be taking the suction and it will be delivering back to the tank. Means through this, and also we will be having water up to this point. So always we will be having water up to this point. So since we have everywhere we are having water, since it is a closed loop, gravity is not mandatory. But in any case, if the pump needs to lift the water beyond the water level of centralized water heater, sometimes it's a closed loop only, definitely. In some cases, if it is an open loop, Means if any case, if the pump needs to lift the water beyond the water level of centralized water heater, then that height you need to consider as the static head. Otherwise, normally that is very negligible only. So in centralized hot water system, it's a closed loop only. Everywhere we will be having water always. The role of this pump is to circulate the water through the loop only. The calculation is different. How much heat that is dissipating to the surface of pipe. Accordingly, we will be calculating the what flow rate of this pump that we have studied in the hot water recirculation system. So in hot water recirculation pump, it might be timely operated. Once in every 30 minutes it will be working. Otherwise, it might be temperature operated. I mean, if we will be connecting temperature in the remotest point, and if the temperature is going less than 10 degrees Celsius of our demand is 60 degree, and if the temperature is going less than 50 degrees Celsius, the pump will start like that. Timely temperature sensor wise also we can operate it. Two functions. Both the way we can operate it. It depends. Okay, as per the client requirement. So, but the role of this one, no, which one? Hot water recirculation pump is to take the water from the hydraulically remotest critical path. From there, it will be taking the hot water, then it will be giving back. So always, since we are having the recirculation, we can make sure that continuously we will be getting the hot water. That's why in hot water recirculation pump, when you are selecting it, you have to calculate the material loss there. You have to calculate the fittings loss there, and that is fine. Correct, means material loss, fittings loss, and that is more than fine for the proper operation of hot water recirculation pump, because static head is 0 there. Okay, see, like I have explained the closed loop system, open loop systems, negative suction, positive suction. The pumps that we are using in the firefighting pump is also there. Definitely there is an open loop pump, material losses, fittings losses. But the when we are doing the hydraulic calculation of fire pump, that is quite slightly different only will come. The method is entirely different. Hydraulic fire pump selection, sprinkler system selection, using elite hydraulic calculation using elite method. That everything I have already explained in the YouTube. It is already there. There you can watch it. Anyhow, fire protection pump is also definitely an open loop pump. The residual pressure is nearly 6.9 bar in most of the system. We need to consider there. Okay. So, but anyhow, I didn't went through a detailed calculation. It is already there, but people will be having always doubt what all things has to be considered for the various pumps that we are using in the MEP industry. That's why I made this video. Okay, then thank you. Hope it is useful for everyone. Thank you.